Good afternoon to one and all present. I am your professor Kausha Masani. Shall be taking your OS in this semester and also the CC for this semester. Okay, now as I told you that we are going to see the overview of this subject first. So I'll just let you go through a brief overview about the subject. You guys can see my screen?
Yes,
Yes,
ma'am.
ma'am.
Okay, thank you for the response. Fine. See, the subject code is 01CE0401. The name is operating system. Okay, it is a 5 credit subject. So you'll be having 4 lectures in the week and one lab per batch. Okay. Now, I'm not going to explain you the scheme and all. That will be explained again, as I said in the orientation. I'll just go through the contents. There are total of 8 units. Okay. The first unit is about the introduction. What is your OS and what are the basic structures and functions and how OS evolved. All those stuff are covered in this chapter. Then in the second chapter, there is process and threads. Okay, you learn what is process, what is threads, how are you scheduling your processes. Okay. Then there is a concurrency control. That is your third unit, where you are going to learn about synchronization between the processes, your software applications. Okay. Then there is memory management, one whole unit about the memory management of how your OS is responsible for managing your memory, assigning the memory, delocating, allocating. Okay, all that stuff is there in this unit. Then there is a principle of deadlock. What is deadlock? What is how to identify that this can be the deadlock? How to come out of that deadlock? All those things are here. That is unit number 5. Then there is unit number 6, all about file systems. Okay, if I talk about file systems and directories, okay, the most known directory to you guys is in your C language, include stdio.h or stdlib.h. Okay, those are the directories. Examples. So in this file system interface, what you're going to learn is how the concept of file is managed by OS. Okay, how those file system structure is there, how that structure is getting accessed, how you can allocate the memory locations and all that, freeing up the space and all. So this is what there in the file system interface. In the seventh unit, it is again a mass storage structure and IO systems. IO systems means your hardwares and the applications which you are using with the help of your hardwares, how you are storing all those processes, okay? Or you can say the how you are applying the disk and the RAID structure using in this mass storage structures. Fine, so that is what is there in the unit number 7. And in the last unit, it is all about protection and security. Okay. Again, there are many things that we are covering in this protection and security. So we will see that how OS plays the role in this too. Fine. For your reference, this time ideally you have these 6 books. Okay. But if according to me, these 2 books, the first one, Operating System Concepts by Galvin, okay, and modern operating system by Andrew S. Tenenbaum. These are the very good enough books. Fine. Number 1 and number 4, you can take a screenshot of this. Actually, there are these 6 books. You are free to use any of these 6 books. Okay, but according to me, the most apt ones is Galvin, that is number 1. All right, and Tenenbaum, Modern Operating Systems by Andrew Tenenbaum. Okay, that is number 4. Both the soft copies are available with me. This is the view, or say the picture of that book. Okay, and I'll be uploading these soft copies in your e-content also, so do not worry. By maybe today or by tomorrow, I shall be uploading both of these two books. That is operating system. This is by Galvin, okay, and this is the modern operating system by N to 10 and 11. Fine. So these are your two books. Fine. And there is a list of practicals that I'll show you in your lab. Okay. Today we are starting with your first unit. Just let me present my screen of that presentation. Any doubts still here? Anybody? Any questions? Yes or no? Okay, fine, perfect. Just give me a moment, please. I'll connect from my second device too. Okay, fine. See, as I said, we are starting a new semester with a new subject, that is operating system. Unit number 1, the name itself is the operating system. Now, first of all, I want to know from your end that what do you guys see or visualize when you are coming across the word operating system? Anything, okay, in simple words also fine, in technical language also fine, and you are free to unmute yourself. That is more encouraged here rather than chat.
An ecosystem where we do our computational work.
Exactly, correct. Good, Tushar. Anyone else? Window between the user and the system. Okay, correct. Anybody else? You can talk, Smudit.
Interface between user and the hardware.
Yes, bullseye.
A system that manages the computers or anything better efficiently.
Correct. Good, you guys are going good. System where all application performs the task. Yes, you can say a platform. Correct. So basically, you have the idea of what the operating system is. Okay, so this will be an easy way for you, at least this chapter. See, in this chapter, what we are going to see is we are going to see what is your OS. I'll give you the overview, and then we'll see what is the history of OS, how actually OS got evolved, what it was previously, then after the inventions and discoveries, how your OS has evolved over the time. That is what we are going to see. Okay. Then in the next topic, we are going to see what are your functions of OS, the primary functions. Okay. Although the modern operating system is having tons of functions, but what are the base of those functions? Okay. So those are your protection and security, your distributed system, and the services which your OS is providing. Okay. You can say in a way that you can structure them into these three categories, though there are variety of structures, but this is how you can ideally classify the functions of OS. So that is another topic that you are going to see in this chapter. After completing that, we are going to see what is your OS structure look like. Okay, we'll discuss what is your OS structure, and then at the end it is system calls and their workings, how OS is accessing your commands, how it is processing it, how hardware is working on those, okay, and how you are getting your output back. All right. So system calls and their working is the last topic. So these are the topics covered in this chapter. Now going to the very first thing, that is OS overview. So can you guys first of all tell me what are the basic elements of present day computer system? Basic elements. And I'm talking, see, there is present day is in caps lock. Okay, so I'm not talking about the older versions. I'm talking about the present. Okay, graphical interface, user interface, okay, GUI. Then CPU, exactly. You can talk, guys. Unmute yourself and answer. GPUs, yes. RAM, very much essential. Hardwares and softwares. Okay, Rishabh, this is very generalized answer. Uh, Correct, but it is very generalized. Monitor, keyboard, mouse, yes. Correct, correct. Right. Now, if I want to again categorize them, all of you are right. Processors, system buses and all. All of you are correct. Everyone. Okay. But if I want to categorize them, like I these computers, RAM, GUI, I can categorize them into one section. Okay. So if I want to do that, then how can I do that? See, mainly uh, if the present day elements, if I'm categorizing them into, then your first category is of main memory. Okay, it is volatile in nature. Okay, also referred as your RAM. Fine. Then there is ROM. Okay, can anyone tell me the full form of ROM? ROM.
Read only memory,
Correct. And your full form of RAM?
random access memory.
Exactly. So these you can say you can categorize them into one section called main memory. Okay. Then there is another section that is IO module. Okay. Any interaction between your input output devices, all right, you can categorize them into IO module. What you can say about these IO module? They are responsible to move the data between the system, okay, and your let's say peripheral outer devices like your storage devices or communication devices, or in simpler words, your input devices. Okay, so this is one category, again an IO module. Okay, third category is your processor. Okay, now this processor is responsible for two things. If we create a flowchart, then this processor is responsible for two things. One is your CU, that is your control unit, okay, which controls all the operations. And another thing which the processor does is your ALU, that is your arithmetic logic unit, processing your arithmetic data. Okay, so this processor basically is responsible for two things. One is your control unit, which controls all the operations. Okay, and second is your ALU, that is arithmetic logical unit, that is your arithmetic and processing your data. Okay, so this is one section. All right, and the last one is your system bus. Now, are you familiar with this word, system bus? Anyone? Okay, anybody want to take a hunch what it might be?
Ma'am, system bus is basically the connecting units between the two or more elements of the computer system that transmits data.
Exactly, correct, Smriti. And I guess Rishabh took a try. Yes, a good try, Rishabh. And partly it is right also. See, your system bus is responsible for communication between your main memory and your input output modules. Okay, how it works, how exactly it is taking the instructions. it is all there in one of the subject which you are going to learn in future semesters also. But regarding with OS, you will get this particular topic in your future units too. Okay, right now you remember this system bus as responsible for communication between main memory and your IO modules. Okay, I'll revise this very quickly. First, you can say the basic elements of your computer system. First is your main memory. Okay, you can say it is volatile in nature. uh, Primary memory, secondary memory. Okay, primary memory your RAM, secondary ROM. Okay, IO module again, in short, if we can refer, it is like responsible for moving the data between your computer system and your devices, outer peripheral devices. Okay, processor again responsible for two things. It does two major, it is responsible for two roles. That is your control unit. Okay, now control unit is what controls all your operations. Okay, and there is one ALU, arithmetic logic unit, which is responsible for arithmetic and processing the data. Okay, so that is the work of processor. And at the last, there is system bus. Okay, it is responsible for communication between your main memory and IO modules. Clear these four things?
Hello,
Yes,
ma'am.
Priyanka.
Ma'am, your screen is not visible.
Is it so? Others?
No, ma'am, it is visible.
Yeah, because it is in my device also, it is visible on other device. Priyank, you rejoin the session. Okay. Students, any doubt here?
No, ma'am, it's clear.
Okay, fine. So now we are moving on to a little bit of history part. Okay. Uh, See, for most of you, history might be boring, but I have tried to make it an interesting also. There is one more slide for the overview, and then there is a history part. So let's go through that. See, if I summarize this whole overview in one slide, okay, then you can say that a computer is having some hardware components like your keyboard, monitor, your CPU, mouse. Okay, and if you see at the back side, there will be some USB ports, printer interfaces. Okay, there will be mouse jack, RJ45 jacks. Okay, video outputs and video ports and connectors, all that. So you can say a computer is having some hardware components like these. But the real question here comes is what? That who is responsible for providing the services of these components? Okay, you do have components, but who is going to provide you the services, or say how the operations is getting managed between these? So your answer here is your OS. Okay, your operating system does all those stuff. Now, what exactly, if we talk about the overview, what your operating system does? See, it is managing your computer hardware. Okay, so in short point, if you want to write, it is a program that manages your computer hardware. First thing. What another thing it does? It provides a platform for your application programs. Okay, your software programs which are running in your devices, whether it is desktop or laptop, or even your phones, or say tablets. Okay, it provides you the basis, or say the platform to run your applications. Okay, again, as you guys have already answered, it acts as an interface, or you can say an intermediary between the computer user and the computer hardware. So it acts as a bridge, you can say, for your inputs, okay, and the hardware which is computing those inputs. Right? The very famous OS currently is, first of all, which one is this? Come on.
Windows.
Exactly. Then you guys tell me which OS you know which are who are currently running in the market.
Linux, Mac.
Linux.
One by one. Okay, Linux is there, DOS is there. Okay, Mac, correct. Ubuntu, okay. Any mobile OS? Android,
Android,
okay. iOS, okay,
Symbian.
correct. Java, iOS, okay, okay. See, there are few examples of OS. They are mixture of your, mobile OS and batch OS. We'll see what are the types of OS also. But if I have to give some few examples, one is Windows, okay. Then there is Linux, your Mac OS or iOS, Ubuntu. Anybody remembers which one is this OS? Any idea?
Oxygen.
Correct, Priyank. OnePlus users will be knowing this, maybe. Oxygen OS, it is a mobile OS, okay, and your Android. So this is not completely just desktop, or you can say batch OS or any particular device OS. This is mixture of your mobile OS, batch OS, okay. Now coming to the history part, can anyone tell me who was the first one to make computer? Anyone remembers?
Charles Babbage.
Exactly. IBM Vijay evolved after like 1940s. Okay, before that, uh, the first computer, also known as analytical machine, was built by Charles Babbage. Okay, but it was just a machine. All right, it was not doing anything apart from simple mathematical calculations. Okay, so what Babbage did was he realized that he needs some software for doing more than mathematical calculation, and thus he went to a woman named Ada Lovelace. Okay, now she was the woman who is believed to recognize that this analytical machine should not only do the calculations, but it should also do some applications. It should also run some applications apart from mathematical calculations. Okay, and she is believed to be the first one to write the algorithm to carry out such applications in your machines, or you can say at that time what it was known as analytical machine. Okay, so that is what it is written here in this slide. Now, if I go through the history, okay, there was the first generation. Your OS is divided into a set of generations. Okay, the first generation computers, or you can say OS, uh, that came around into your time of 1945 to 55. Now, anyone remembers what those first generation, or do anyone have idea what those first generation computers were working on? If you have read somewhere, this is because this is general knowledge regarding your stream. Transistors, okay,
Vacuum tubes.
correct,
Vacuum
correct.
tubes.
Transistor is correct, but
Transistors.
they are not in your first generation.
Transistor is very in second generation.
Correct. Absolutely right. See, in your first generation, there were vacuum tubes and plug boards. Okay. So there, what your devices would look like, they were the size of your rooms. Okay, there were strings of vacuum tubes going on, and there were plug boards. Those plug boards were having some, plugs with letters and numbers and assembled in them. Okay, so what the programmer or the operator used to do is he would, take the calculation on pen and paper. Then he would go inside to that room. He would put on those, he would start those vacuum tubes, and in those plug boards he used to give the inputs using the plugs. Okay, and then the machine would start running. It would run for a day or a two, and afterwards there was an output. Okay, so your first generation used vacuum tubes and plug boards. The size of the machine, as I told, is was as big as your single room. Okay, and these programming was all done with the machine language, so your zeros and ones. All right, and you were giving the input by wiring the plug boards, as I explained. This is what it looked like. Okay, there, see, if you can see, there is an operator who is putting the input into those plug boards, and this was, the room was, the machine was as large as your room. And if you want to see the plug board, it would look something like this. Just let me zoom it. Okay, see, you can see some, you can make out some letters and some numbers in these plug boards. Okay, and you had to plug in those tubes inside those. Okay, and that's how the input were given. So this is what your first generation computer system were looking like. It was like this. Okay, later, when this OS got evolved, okay, now, because see, your output, you cannot wait for your output for 2 day or 1 day to come out and process your calculation. So what they did was they innovated, or say they sped up the system. Now you can classify them into the second generation. Now second generation, the year was between 1955 to 1965. Here, what you guys have answered, the transistors, because transistors came into picture at that time, they started using transistors into these machines. Okay, so now vacuum tubes and plug boards got replaced with transistor and batch system. Okay, now what these used to do, let me show you with the help of an example. Okay, these are the system. This 1401 is one system. Okay, this 7094 is another system. Okay, and again this 1401 is one system. Now what they used to do is, first of all, the programmers were writing the programs into one card. Okay, and these program card were known as jobs. Okay, so the programmers, what they used to do is they used to bring those stack of programming jobs to this device, that is your 1401. Okay, there was a card reader which used to read these jobs, and it used to write in one tape, big tapes. Okay, so once you place this, okay, this machine used to read those jobs, and it used to write on the tapes. There were, if you can see in the, if I can reference it, everybody must have seen Marvel movie, Winter Soldier, Captain America. They were inside one room called Hydra, where they started the system. There it was the database, and it was running on tapes. You can see that scene. That is for the reference, if I can give you what where the tape drives look like. Okay, so these machines used to read the jobs on the tape. Once they are written on the tapes, okay, those tapes were taken into these 7094. Okay, so there was another operator who used to take those as an input tapes. Okay, so tape rewound, mounted on the tape drive into the machine room. Fine. So these input tapes then used to get processed by this 7094 machine. All right, all the processing were done by that. So this machine is operate on the jobs with the help of a special program. This special program is nothing but that time OS. Okay, and all the outputs were not given directly. Okay, all the jobs, suppose there are 5 jobs written, then first job output given, second job output given, that was not the thing. Okay, this system tape used to write all the outputs on one another output tape. Okay, all the answers, suppose the first job was addition, 5 plus 5. Okay, second job was subtraction, 20 minus 10. Okay, then it did not used to give that, okay, for first job this is the output, for the second job this is the output. No, not like that. It used to uh, accumulate all those results into the output tape. Okay, and once that output tape is ready, it used to go back to that 1401 one more system, where it used to print all the outputs to the machines. Okay, so this was the whole, you can say, the process of how those second generation computer systems are working using transistors and batch. Okay, now what evolution, what plus things that we did, or say what were the improvisations with comparison to your first generation, was machines are now getting called mainframes. Okay, and they were now in an air conditioned computer rooms. Previously they were just, vacuum tubes, so, and plug boards, so you did not need any special room for them. But now, as we are using transistors and batch system, we are calling them as mainframes now. Okay, and they needed a special air conditioned computer rooms. Okay, with professionals who are running those computer systems, or say the special program. All right, and what were these used for? Basically for your scientific and engineering calculations only. Okay, nothing else, nothing apart from else. Just for scientific and engineering calculations, these second generation computer systems were getting the jobs. Right? Clear till here, everybody? Okay. Yeah, one more thing. These programs were largely, now programmed in assembly language and Fortran. Fortran is again one language. So what plus that we did apart from your first generation is that first generation we were writing the codes in machine language. Now in the second generation we are writing codes in your language called Fortran, okay, and assembly language. Any doubt in these two generations? I hope not. Still any doubts? Anyone? Any questions?
No, ma'am.
Okay. Now, as the time evolved again, as we are moving ahead of the times, we got our third generation. The third generation time duration was between 1965 to 1980. Okay. Anyone have any idea? Apart from now batch system and transistor, what add-on we did so that we are now in third generation?
Integrated circuits.
Exactly. Absolutely right. For all those who are answering in the chat too, and Vijay, right. Now you are getting your ICs, and multi-programming came into the picture, because there we came into your integrated circuits. Okay. Everybody, I guess, is very much, at least have seen what your integrated circuit would look like, or at least you just know that there is some green color board. Okay, so IBM's System 360 is the first major computer, you can say, in the line, who was having the integrated circuits, okay, and who was now able to do some application work apart from just scientific calculations and engineering calculations. Okay, so that's here the answer is correct, that in third generation, IBM's System 360 was the first major computer, you can say. Then there were variations. There was 370, and again then Intel came into the picture and all. Okay, but when ICs came into the picture, IBM's System 360 was the first major computer, you can say, that were using the integrated circuits. Okay, so with multi-programming, you can now work with multiple programs. You can load multiple programs in your memories okay, which were having their own memory partitions. Previously, in first and second generation, it was not, the concept of memory was not at all introduced. Okay, but in this third generation, because of multiprogramming, the concept of memory got introduced, and with that memory concept, now multiple programs were able to get loaded. Okay, and they were having their own memory partitions to work on. Fine. Now, because of this, you needn't wait so much, like for a day or half a day, or you have to, wait for the long procedure to load the job, then process those job, then again tape on that job. Okay, all the things were eliminated here, right? And this is what it looked like, the third generation computers. Okay, the integrated circuit, the initial integrated circuit would look like this. Okay, and your very starting third generation computers came with this kind of desktop and keyboard. Okay, there were the era of floppy disk also. I don't know if you guys have seen it or not, but in the hardware also we used to have floppy disk. Okay, CPUs were there. Fine. So this is what the third generation computer looked like. Now, next generation which came after 1980 was your fourth generation. Okay, so 1980 to 2010 was the era of your fourth generation. Now here, can anyone tell me what, apart from IC, now what came here in the fourth generation that we are categorizing them here?
PC.
Very large scale.
Very large scale, what?
Integrated circuit. बड़ी ICI.
Okay, anyone else?
The IC was made more compact.
IC was made more compact.
Microprocessors.
Correct. Absolutely right. The very right word, I can say. Rest of you were also right. And Priyank, OS तो evolve हो ही रही है इसमें, ठीक है? Microprocessors were now getting used. Now, can anyone tell me what do you understand by microprocessors here? I don't seek out technical definition. जो भी आपको समझ में आता है, what do you understand by microprocessor? You tell me.
One chip, like one very small chip which has lots of transistors on it.
Correct? Anybody else?
Size of transistor is in micrometer.
Exactly. See, your microprocessors, where your if everyone is right, but in parts. So what I'm going to do is I'm going to uh, join those parts now. Your microprocessor, where those integrated chips, okay, where the hardware were mounted, but in a very small scale. Though the hardware size was scaled to a smaller version, but the work of these ICs, it you can say it enlarged into a very large section. Okay, so microprocessors, you can say these are highly integrated chips, fine, who are now able to do major calculations and many calculations, or you can say multi-programming at a time. Fine. So that was the one thing which we upgraded from third to fourth generation. Intel came into the picture now. Okay, they were the chip makers who developed your Intel 4004 chip. Okay, in 1971, and it what it did was it positioned all its computer components into a single chip. So CPU, memory, input output IO controls, okay, everything these microprocessor chips were able to do, or say able to handle. Okay, so Intel came into the picture at that time. Again, as you guys said, large scale integration. Okay, very large scale is currently going on. Okay, VLSI. But the development of, first of all, large scale integration circuits came into the picture because of these microprocessors. Okay, and you guys have, as I said, exactly and correctly answered. The chips were containing thousands of transistors in your square centimeter of silicon. Okay, so the size of these hardwares, these transistors, reduced, but the work of these processors, or say the chips, okay, increased to a very high number. Okay, and as you know, the chip makers, there is Intel, then there is AMD, ARM is there. Okay, all these started producing these highly high-ended devices, which are the fourth generation devices. Okay, now the present generation, that is the fifth generation. Okay, 2010 and present. Can anyone guess what this present generation is working on now, or where we are going to end up?
Artificial intelligence.
Exactly. Artificial intelligence is now getting used. Anyone aware exactly how this artificial intelligence is getting used? Any example?
Prediction.
Correct. Prediction is there. Then
Taking intuitive steps by non-programmed, but
intrusive steps. Okay. Good efforts from all of you. Anyone else?
Automation of tasks.
Automations. Correct. Anyone heard about holograms? AI assistants? Yes. Holograms? Anyone?
Yes, ma'am. Yes,
Where it
ma'am.
is used? Anyone can give me one example where holograms are used?
Ma'am,
Okay,
is
one
it
example.
supercomputer?
where
Ma'am,
people
it can be
cannot be
used. Ma'am,
present
it can be.
in live.
Ma'am,
Yes,
it can be used for remote seminars.
correct. Absolutely right. Or in advertisements also. Advertisements of any product which you want. Okay, so holograms are used at that time. So the present generation, that is the fifth generation, which started from 2010 and presently going on. Okay, now it is getting, it is using your AI, that is artificial intelligence. Okay, the computer devices, though, although you cannot say that they are completely developed now into artificial devices, or you can say using complete artificial intelligence, but yes, we are using AI in some of our applications and programs. They are yet in process of development where a computer is completely using AI. Okay, again, because of AI, parallel processing and superconductors and supercomputers are possible to make. Fine. And maybe in future, okay, the computers are going to be transformed radically, again, into quantum computations, or you can say nanotechnologies, or molecular technologies too. Okay, but that is the future prospects. And somewhat you can say the present systems, your fifth generation, looks something like this. Okay, where you don't have any restrictions of how your display look like. Your display can be horizontal, your display can be vertical. Okay, you don't need big CPUs or say batch systems or transistors in that room. The size is actually reduced. Okay, there is palm tops, there is laptops. Okay, there are tablets now where you are working, you're processing, your applications are running. So this is how the OS so far is evolved, right? And it is still evolving, it has not stopped. Okay, so any doubt here, anyone, till this slide? Yes or no, students?
No, ma'am.
Okay, fine. So I guess you guys have understood what these generations are, how we are upgrading with each and every generation. Okay, so there is one task for you. Okay, what is the task? You have to write examples of first generation to fourth generation computer systems. I need minimum 3 names. Okay, the examples, I just want names, nothing else. Okay, like first generation you give minimum 3 names, second generation you give minimum 3 names, along with 2 disadvantages, or say the shortcomings. Okay, what are the 2 disadvantages, or say why, in another words, if you want to say that why we evolved from first generation to second generation. इजी वर्ड्स में बोलूँ तो क्या ऐसी ज़रूरत पड़ गई थी कि मैं फर्स्ट से सेकंड में जाऊँ, सेकंड से थर्ड में जाऊँ. ठीक है, सो यू हैव टू गिव जस्ट नेम्स like first generation 1 2 3 names. Okay, and 2 disadvantages. Okay, 2. Now how you are going to do this task? After this session I'm going to share you the Google Classroom link. Okay, and this time I am going to do the continuous evaluation. You'll get these kind of small tasks. Okay, and you have to write your answer in that Google Classroom itself. Fine, and I'll be grading those answers continuously. And but the thing is, you will get very short period of time. Okay, you won't get 1 week, or you won't get 2 days. If I'm discussing this task here today, then by next lecture I want the answers to be submitted. So whenever there is a next lecture, I want answers from all of you. Okay, due to any reason you are absent, okay, in the session, you did not get, then it is fine, but it is mandatory for all to write the answer. Okay, this will not only keep you updated with the ongoing session, but you will need less time to revise also whenever you are revising the concept. Fine, so this is the task for you. Task is, again, just repeating for your sake, फर्स्ट से लेके फोर्थ जनरेशन तक के कंप्यूटर सिस्टम्स के सिर्फ नाम लिखने हैं. ठीक है, 3 names per generation. Along with that, for each of the generation you have to write 2 disadvantages, और वो भी गूगल क्लासरूम में. ठीक है, 10 marks for this question. I shall be grading individually all the students. You'll get an invite in your respective institute email IDs. Kindly accept those class invitations. Okay, assignments is also there this time, and I will give you the information about that assignment in the next session also. Okay, now just we have 5 minutes more, so I'll tell you what we are going to do in the next session. So if you want to just look at the overview of this topics, you can come up with that. In the next session, we are going to see what are the goals of your OS. Okay, we are going to discuss what is the actual goal of your OS. Okay, we will discuss what is the function of OS. After that, all the given functions of OS that shall be discussed. Now in the goals of OS, you have primarily 2 goals, that is primary and secondary goals. What are those, how they play role, and how OS is playing the role? That is what we are going to see in your next session. Okay, we are keeping this session till here. Thank you all for attending, but there is one more instruction, so kindly do not leave the session. I'll just take your attendance first. BD students 1 to 15, write the numbers in the chat. Yes, and that roll number writing rules remains the same. Okay, whatever we followed in DS, that same rules applies here. And do not leave the meeting. I still have instructions to be given. Okay, D2D students, numbers in the chat. Okay. AI, regular students 1 to 10. Eleven to 20. 21 to 30. 31 to 40. 41 to 50. 51 to 60. 61 to 75. 'Okay, suppose everybody has written. Okay, noted. Fine. Thank you all.